I am Farah. Now, I want to explain about our hopper design. What is hopper? Hopper is a type of container or silo that store the bulk materials, typically one that tapers downward and is able to discharge its content at the bottom. In our design, the type of hopper we use is the conical hopper. Next, I will proceed to the type of flow pattern in hopper design. There are two types of flow in hopper, which are mass flow and funnel flow. In mass flow, the entire bed of solids is in motion when material is discharged from the outlet. This behavior eliminates the formation of stagnant regions in the vessel, and affords a first in, first out flow sequence, which provides a more uniform velocity profile during operation. By contrast, in funnel flow, an active flow channel forms above the outlet, but stagnant material remains, called earth holes, at the periphery of the vessel. Funnel flow can cause erratic flow, exacerbate segregation, reduce the live capacity of a vessel, allow particle degradation, leading to caking and spoilage, in stagnant regions. In our design, the flow of wood pellets is a mass flow.
From the given data, the effective angle of internal friction is equal to 40 degrees, whereas the kinematic angle of wall friction is 19 degrees. From the hopper flow factor values for conical hopper graph, we get the hopper flow factor as 1.5 and the semi-included angle of hopper slope is equal to 25.2 degrees. From the materials flow function in the research article, the minimum outlet width or diameter of hopper can be determined using the hopper flow factor value. Janik defined the flow factor equation as FF equal to sigma C over sigma Y, or sigma Y equal to 1 over FF times by sigma C. This may be plotted on the same axes as the powder flow function on confined yield stress and compacting stress in order to reveal the conditions under which flow will occur this powder in the hopper. The limiting condition will give a straight line of slope 1 over FF. Figure 2 shows such a plot. By assuming the values of sigma C in the equation of limiting condition, we can get a straight line of 1 over FF.
This is our plot of the unconfined yield stress, sigma Y, against the compacting stress, sigma C. Next, we will proceed to the minimum outlet diameter. To calculate the minimum diameter of hopper outlet, B is related to the bulk density and the critical stress by the relationship as below. B is equal to h theta times by critical stress divided by bulk density times with gravitational acceleration. Note that h theta is the slope of hopper wall. An approximate expression for h theta for conical hoppers is given by the relationship as h theta is equal to 2 plus theta over 60. From the industry of wood pellet storage volume, the material of hopper silo is steel silo with conical bottom. The diameter of hopper silo is 4.58 meter. The capacity of hopper silo is 112 tons and the hopper bottom height is 3.21 meter. The silo bin height is given as 7.91 meter. For circular hopper, from the reference dimension, which is diameter given, we can calculate the volume of hopper using the given formula. V equal to 0.262 H times by D1 squared plus D2 squared plus D1 times D2. Thus, the volume of conical hopper is 21 meter cube. The formula to find the volume of vertical silo is V equal to 0.785 D squared times H. Based on the heuristic of the vessel, the optimum ratio of length to diameter is equal to 3. But the range is 2.5 to 5 is commonly used. Thus, we assume the length, L equal to H, therefore, L over D is similar to H over D equal to 3. Then, H is equal to 3D. The volume of vertical bin is 226.24 meter cube. But, the total volume we get from the circular hopper and vertical bin is 247.24 meter cube. Next we will calculate the mass discharge rate of wood pellet from hopper outlet. We assume that we wanted to store the wood pellet for 1 day and then we will refill them back into the silo after 1 day. The mass of wood pellets is 153.54 times 10 power of 3 kg. We divided the mass of wood pellets by 24 hours and 3,600 seconds, we will get the mass discharge rate of wood pellet from hopper outlet, which is 1.78 kg per second. Thus, our design hopper with the minimum outlet diameter of 0.75 have an approximate mass flow rate of 1.78 kg per second.
Audio Jungle.
Next section is fluidization. What is fluidization? Fluidization is a process happens in fluidized bed. Fluidized bed technology is considered as one of the most suitable choices for biomass conversion because of its fuel flexibility. The fluidized bed that we used in our design system is fluidized bed combustor, FBC. The operation temperature we used in FBC is 800 degrees Celsius and at 1 atmosphere pressure. Let's take a look what happens in fluidized bed combustor. After our particle, which is wood pellet with a mean size diameter 8 mm and length 20 mm, are being transported from the pipeline using pneumatic transport system, the wood pellet is combusted in the FBC. Using air moving in upward direction through a bed, it acts as a fluid and source of oxygen, hence combustion occur. Here is the crucial part in producing the fuel gas, which is our desired product. The ash is moving out from the bed and moving to waste treatment before being disposed. Okay, so now let's us consider why we need to fluidize the particle. In our design it is important for us to fluidize because of first, to allow all the particle of the wood pellet to 100% burn in air, and secondly because we need to have entrainment of ash so that the ash will not accumulate at the bottom part of the bed and distracting the process. The question is how to make sure the particle to entrained or fluidized. First we must know the condition that we need in order to fluidized to occur. It is operating velocity. VT should achieve minimum fluidization velocity, UMF. After calculation of VT and UMF has been made using the calculation and the formula, it is proved that fluidized will occur as the Vermont is greater than incipient velocity. The value is acceptable condition for the process to fluidized or entrained, hence it can be concluded that the ash is moving out of the bed and no accumulation inside the bed. For the calculation of UMF and Vermont, the density particle we used is not wood pellet density and it is ash wood pellet density with a value of 200 kg per meter cube. The reason why we used ash in calculation because our aim is to fluidize, entrain the ash. There are a few limitations in our process as the particle that we used in calculation falls under Group C according to Geldart's classification. It is cohesive material and difficult to handle. Some may still accumulate event off the velocity is higher than its incipient velocity. In order to entrain this kind of materials, vibration can be introduced. The fuel gas product is the useful product to generate power and electricity.
you.